Welcome back to G Fun Facts Online, your go-to source for the most fascinating insights from around the globe. Today, we're diving deep into a revolution that's happening right now, not on the streets, but in the quiet, sterile halls of scientific research. Imagine algorithms whirring and data streams glowing. Artificial intelligence, or AI, is no longer science fiction. It's a powerhouse actively changing how we understand everything, from tiny atoms to the vast cosmos, from miracle materials to life-saving medicines. But this isn't just about cool science. It's about money, big money, and a whole new way of thinking about economic value. As AI transforms from a mere tool into a research partner, sometimes even making discoveries on its own, we've got to ask, how much is automated research actually worth? And what does AI-driven science mean for our wallets and the global economy? Traditionally, a scientific breakthrough takes ages, costs a fortune, and is incredibly tough work. AI is here to flip that script, promising to shrink timelines and slash costs. Think about AI sifting through mountains of genomic data to find potential drug candidates in days, a job that would take humans years. Or picture AI designing brand new molecules for better batteries or greener plastics, even tweaking experiments in real time to boost success and cut waste. We're witnessing the birth of AI-augmented and, increasingly, AI-automated science. So where is AI making its biggest mark? Let's look at the engine room of discovery. In drug discovery, AI is a game changer. It helps identify targets, design molecules, and predict if a drug will work and be safe. This could dramatically shorten the decade-plus billion-dollar journey from lab to pharmacy. McKinsey even estimates generative AI could add up to $110 billion annually to the pharmaceutical industry by speeding up drug development. Some AI-focused biotech companies are developing drugs at a fraction of the usual cost. The global AI and life sciences market. It was around $8 billion in 2023 and is expected to shoot up to nearly $34 billion by 2029. That's massive. And it's not just medicine. Materials science is another hotbed. I can predict properties of new material combinations, speeding up the discovery of stuff for stronger, lighter products, super-efficient solar cells, or catalysts for green tech. Researchers using AI are finding way more new materials, leading to more patents and innovations. This isn't just about doing things faster. It's about finding things we couldn't even dream of before, because the possibilities were just too complex for the human brain alone. Beyond that, AI is digging into climate modeling, particle physics, astronomy, and environmental science, helping us analyze massive datasets, spot hidden patterns, and even run experiments in self-driving labs. Imagine a lab that never sleeps, constantly testing and learning. Now let's talk about the economic calculus. It's a balancing act between costs and breakthrough benefits. On the cost side, it's not cheap. Developing or buying fancy AI models, building powerful supercomputers, gathering huge high-quality datasets, and making sure that data is findable, accessible, interoperable, and reusable, or fair, plus hiring AI experts, all costs a pretty penny. And let's not forget the energy needed to train these giant AI models. That's a growing concern too. Governments and private companies are stepping up though. The U.S. Department of Energy announced $68 million for AI in science in late 2024, and the National AI Research Resource Pilot launched in January 2024. Canada's putting in $2 billion for its AI compute strategy, and the EU is aiming for 20 billion euros a year. Venture capital is flooding in as well. But what about the returns? This is where it gets exciting. First, accelerated discovery. AI dramatically cuts down research time. That means faster solutions for huge global problems like pandemics or climate change. AI can slash time to market for new products by 10 to 20%, sometimes even more. Second, boosted productivity and efficiency. AI automates the boring, repetitive tasks, freeing up human scientists for big-picture thinking and creativity. Some companies report potential R&D cost cuts of up to 25%. Third, novelty and radical innovation. AI can spot patterns humans might miss, leading to completely new ideas and game-changing inventions. Fourth, reduced failure rates. In areas like drug discovery, where most attempts fail, AI can improve the odds of success by predicting problems early on. And finally, economic growth. All these scientific advances lead to new products, industries, and jobs. Estimates suggest AI could add trillions to the global economy by 2030, partly through this innovation boom. So it sounds amazing, right? But here's a tricky part: putting an exact price tag on AI-driven insight. How do we calculate the return on investment? It's tough. For instance, how do you separate the AI's contribution from the human scientists? Discoveries often take years, even decades, to become marketable products. And what about basic research? The kind that expands our fundamental knowledge, but doesn't immediately sell anything. Its value is immense, but hard to quantify. Interestingly, AI can also tell us what to want work, saving tons of time and money. These negative results have huge economic value and cost avoidance. And how do you put a dollar value on a life-saving drug, or a breakthrough in clean energy, or understanding the universe better? The societal benefits are often priceless, even if they have indirect economic impacts. Despite these challenges, the trend is clear. The economic contributions are huge and getting bigger. This AI revolution is also reshaping the scientific workforce. Are scientists going to be replaced by robots? Probably not entirely. But the job is changing. We need more scientists who are AI savvy, good with data, and can work alongside AI tools. Think of it as a centaur model, human intelligence boosted by AI. Routine tasks might get automated, potentially shifting some technician roles, but new jobs will pop up focusing on AI development and interpreting AI's findings. There's a real need for scientists to reskill and adapt. Then there's the thorny issue of intellectual property. Who owns a discovery made by an AI? Current patent law usually says an inventor has to be human. So, if an AI designs a new molecule with minimal human help, who gets the patent? The AI developer? The person using the AI? Or does it become public knowledge? This is a massive question because patents drive commercialization and investment. Courts and patent offices are still figuring this out, but right now, they lean towards needing significant human input for IP protection. This uncertainty could make investors nervous, and of course we can't ignore the ethical side and making sure everyone benefits. AI models learn from existing data, and if that data has biases, AI could make them worse, leading to skewed research or missed opportunities. Then there's access. The high cost of AI could create a gap between rich and poor research institutions, making global inequalities in science even wider. Initiatives like the US's NAIRR and global AI funds are trying to fix this by democratizing access. Also, some AI models are like black boxes. We don't always know how they reach their conclusions. We need transparency and accountability for scientific rigor and public trust. So what's the path forward to really unlock AI's economic potential in science? We need strategic investment in AI research, better infrastructure like computing resources and shareable fair data, and more skilled people. Public-private partnerships are key to turn discoveries into real-world applications. We need smart, flexible rules, especially for IP and data, that encourage innovation while managing risks. Promoting open science and data sharing while respecting IP can speed up AI development globally. And our education systems need to change to prepare the next generation of scientists for this AI-driven world. In the end, AI in science is more than just a tech upgrade. It's a fundamental shift in how we create and use knowledge. The economic ripples will be enormous, promising faster innovation, greater productivity, and solutions to humanity's biggest challenges. Yes, valuing automated research is complex, but the potential for massive economic and societal rewards is undeniable. To navigate this new frontier, we need to be smart about costs, strategic about benefits, and committed to ethical, fair development, ensuring this new dawn of AI-driven science shines on everyone. That's all the time we have for today on Fun Facts Online. Join us next time for more fascinating insights. Thanks for listening.